In this video, I'm going to prove the formula for n choose r. Remember that n choose r is the number or amount of r element subsets of a set with n elements. So we need a set with n elements. So let's say that this is that set. So this will be our set with n elements. A1, A2. We'll put AR somewhere in the middle there. AN, something like that. Remember that for n choose r to work, we need r to be between 0 and n inclusive. Here I've put r where it is strictly less than n. That'll make what I do here more interesting. Okay, so the first thing we have is r permutations. R perms. So I'm going to write over here some of the r permutations. I can't write them all out because we don't know what n and r are. But let me write some of them. Okay. So let's say A1, A2, and let's see, maybe A2, A1, A3. Let's say 3, A2, A1, up to AR. And there's lots of these things. Let's see, and we just keep doing this. We keep finding different permutations of the elements A1 through AR. So we're finding the permutation, so we're doing permutations of length R. So some of the permutations of length R are different ways that you can permute the elements A1 to AR, and that's what I have here. Okay. So we just keep doing that, and then what comes next? Let's say AR minus 1, A3, A2, A1. All right, so there's a lot of these. Dot, 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 dot. We could think of this as the set P that we have for permutations. These are R permutations. All right, and then over here we'll put the set S again, the set S of all subsets of the set A1, A2 up to AN. The set of all R element subsets, not the set of all subsets. Let me correct myself, not the set of all subsets, but the set of all R element subsets. And so one of these many subsets here, one of these many R element subsets is the subset A1, A2 up to AR. And again, we can imagine a mapping or a function from the set of all R permutations to the set of all R subsets. All right. And what this does maps all those to there. All right, so the cardinality of S, this is 1 over the number of different ways that you can, the number of different things that come over to each one of the elements of S. Right, so we need to count the number of ways that we can, the number of these red connections, right? The number of these red arrow connections that go to each one of these elements in S. This will be times the cardinality of P. Now, what I have here, what I've drawn here so far, right? This is just one of these situations. So for each one of the different subsets of S, you have, and let me just draw another one. Let's say that we had, what's another subset of S? R element subset of S. I don't know, say maybe A2 to A R plus 1. Right, how many elements are in there? So there's R element, that's an R element subset of S, and then there will be some amount of arrows coming over to here from our set. Okay. So it really just comes down to how many things come over to each thing. So how many elements of P get mapped over to one element of S? And we can count these. So every element of S has the exact same number of elements of P that are mapped over to it. And so because of this example here, what I have here, we can count these. Okay, so there's R positions there. And so you have R choices, A1 through AR there, R minus 1 there, R minus 2, R minus 3, all the way down to 1. So that's R factorial. So the number of things here, this is R factorial. So this is R factorial there. But remember the cardinality of P, right? This is just the number of permutations, of length R, the number of permutations of length R, where chosen from n symbols, right? So, and there's a formula for that. There's a formula for remember the cardinality of P. This is P n R, which is equal to what I'll put there. Right, remember this was the cardinality of P there. So that's n factorial over n minus R factorial. So putting it all together, we have the cardinality of S is equal to n factorial over R factorial, n minus R factorial. All right, now what's the cardinality? So what is S? S is the set of all R element subsets of a set with n elements. All right, well that's exactly what n choose R is defined to mean. So that is the formula.